He's not gonna know.
He doesn't know.
He's not gonna
How
know.
did we get to the corresponding? I hope he can make that leap. Yeah, so angles A and E are called corresponding and same side.
Angles.
Oh, same side angles. Or same side,
Exterior.
no, they're
Same side alternating, right?
Alternating.
Because we have an interior and an exterior. B and C are called what?
I don't know this one.
I know that opposite.
Opposite, yeah. For one. Yeah. And the second one?
Of course.
No, not correspond. They'd be
So we said they're opposite.
alternate angles, opposite and
Si-
alternating angles.
B and E.
B and
We called it, so B and C, yeah. We said that they were opposite
and alternating.
opposite and
Oh no, they're not.
corresponding, right? Because they're the same size. Okay, angles C and F.
Opposite interior angles.
Perfect. So, I'm gonna say alternate.
Yeah.
Alternate. What do we have? C and F. Alternate interior. And what? Are they the same?
Yeah. Same angle. Yes.
Same angle, right? Yeah. Good. Okay. Yeah. So I guess we should call them corresponding. Hey. But they are on C and F. We're both interior, so it can't be corresponding. So we'll just call that one alternate interior. Okay. B and G are what?
Exterior.
Alternate exterior. Good. Good. D and F. D and F. These guys right here.
Interior corresponding angles. Oh no, interior same side angles.
Yeah, same side. Interior. Okay, and last one, B and H.
Same side exterior.
Same side exterior. Okay, sure.
Or I guess.
Same side exterior, right? Up B and H? Yeah. Good. And how many total degrees are there in an n-gon? I know we already talked about this today.
Oh, -2. Oh no, that's not degrees, is it?
So n minus 2. And then what am I going to multiply that by? 180. Good. Good. Excellent. Okay, so we are in topic 2.5. Okay, so question for you guys. What is the difference between similarity and congruency? What does similar sound like?
Similar.
Oh, congruent's like being exactly.
Okay, perfect. Perfect. So,
Similar means like they have the same shape.
yeah, you are definitely on the right track. So, congruent is exactly the same. Exactly the same. So, same angles,
Different shape.
same side lengths. No, we're going to be doing triangles. So the only shape we're really concerned about is triangles, okay? But congruent, they would need to be the exact same, Logan. Exactly the same angles, same side triangles. Same side lengths. Sorry. Okay, so that is congruent, and similarity This is proportional. Same angles, but different side lengths. Okay, so you might have a triangle like this. Okay, say everything is 1. And then if we just double the size of that, all of the angles will be the same. Okay, but our angles are going to be, our angles will be the same, but the side lengths will be different. Okay, how many unknown measurements exist on any triangle?
Well, 3.
3 what? So 3 is a good number, but what are the possible unknowns for our triangles? What do we have?
3 angles.
3 angles and
Lines? I don't know.
and 3 side lengths.
Oh.
So if you meant lines by side lengths, then yes. Okay, and do I need to give you all of them?
Like
Three-
what? 3 angles and 3 side lengths?
Yeah, to be able to create that triangle.
Yeah. Oh, you can solve for it too.
Right, so I could give you guys like 2 angles, right? And you guys would be able to find that third angle,
Yeah.
right? Okay. So no. No, I do not. You guys are gonna have to do some puzzling pieces together.
So we got my water bottle.
Sure. Okay. All right. Which measurements are we going to need? Okay, so we are going to go through 3 different options. Okay, and then we will kind of go from there. Okay, so option 1, we need all 3 side measures and none of the angles. Okay, so you don't need to use your rulers for this. Okay, but I would like you guys to sketch this still. Okay, so draw for me a triangle that has side length 5.7 centimeters, 4.6 centimeters, and 2.4. So mine looks something like this. .7. Okay? So if all 3 side lengths are the same, are we going to have congruent or similar triangles? If all 3 angles, if all three of the side lengths are the same? Yeah, perfect. Really good. So if we know all 3 side lengths, we're gonna call that SSS. Okay, that's our reasoning behind that. Okay, so SSS, when we know 3 side lengths, okay, this will make congruent triangles. Okay, and this will make congruent triangles. Any questions so far? Do you? Okay, give me 1 second. Okay, so there is our option 1. Okay, this is when we know all 3 side lengths. So we call this SSS. Okay? Option 2, you need 2 side measures as well as the angle contained between them. Okay, that's important that it's in that order. Okay? So, I want you to create this triangle on your page. Brendan, give me one, please. So 2 side lengths, so it's gonna go 2.9 centimeters is the 1 side length. Okay, the angle between these sides that we know must measure 50 degrees. Okay, so if this is 2.9, this is gonna be my 4.6 side, and this is my 50-degree angle. Okay? So there is the rest of my triangle. So if we know 2 side lengths and 1 angle, do you think this will give us similar triangles or congruent triangles? And remember, congruent triangles being the exact same.
I think, similar. Congruent.
Yeah, congruent, right? Because there's only one possible orientation for this triangle to exist, right? We have 2.9, 4.6, and that angle in the middle, okay? There's only one possible way that this triangle can exist, okay? So we are going to say this also gives congruent triangles. Okay, and this is the logic or the reasoning behind that. We're gonna call that SAS. Okay, side, angle, side, in that order. Okay, side, angle, side. Okay, this is gonna help us when we're proving if triangles are congruent or not. Okay, and we need to go over proofs a little bit, and I have your quizzes marked, so we will talk about that in. After we're done here. Okay? So SAS will give us congruent triangles. Okay? Okay, option 3. You know 2 angle measures and the side length between those 2 angle measures. Okay? So create for me a triangle with 2 angles, each measuring 40 and 50 degrees, and the side between them measures 6 centimeters. Okay, so 40 degrees, 50 degrees, and the side between them measuring 6 centimeters. What must my other angle be?
Oh, 110.
Close.
90.
90.
Oh yeah.
So a right angle triangle, this would be, right? Okay, any guess as to what we will call this one for our reasoning?
A right angle.
No, if we know an angle, and we know a side length, and we know an angle, Asa?
Congruent.
No.
Yep. So this is going to be ASA, okay? And this will also give congruent triangles. Okay? That was a good catch. So those are the 3 that we know, okay? So we know SSS, side, side, side. We know SAS, side, angle, side. And we know ASA, angle, side, angle, okay? And it needs to be in that order. So these will give us congruent this will give us congruent triangles, okay? So let's get into an example. Oh, we have one more. Let's skip that. Oh, fine. Fine. We will do this one as well. Okay, so you guys actually use more organized than mine, which is great. So create a triangle with angle measures of 30 degrees, 60 degrees, and 85 degrees. Okay? So we're going to have a really small angle here, almost a right angle, a little bit smaller. Okay, so we have 30 degrees, this is going to be my 85 degrees, and this up here must be my 65 degrees. So, if I know 3 angles, and if you guys were to actually measure, does anybody have a ruler? No? Okay. Brody does. So Brody's going to measure his. I'm going to measure mine. and we probably will, well, I'll just jump ahead and I'll spoil the surprise. Okay, we don't have a ruler in here, that's okay. If we were all to create an angle or a triangle with a protractor, we would notice that all of our side lengths are not the same. Okay? No, they are different.
But what if they weren't?
Then we'd be like, wow, that's a miracle. But yeah, so when you know three angles, okay, this does not give us congruent triangles, but it gives us what type of triangles?
Similar.
Similar, right? Yeah, because
They're close to shape.
the side length, it could be like, it could be 1 centimeter in size, or it could also be like 20 centimeters in size, or it could be like 1 kilometer in size, right? It's just the ratio between the three side lengths. It's like a scale representation, right? Like, you know, when you look at a map, it's like the country, but on a scale representation. It's kind of the same thing as this. If this was 1 centimeter or 1 meter or 1 kilometer, right? As long as we have like the same side lengths or like the same ratio of the side lengths, it will give us a similar triangle, okay? So if you only know the angle measures, is that enough to create a congruent triangle?
No.
No? What type of triangle will we be making?
Similar.
Good. No, it will give us similar. Okay? So again, just going back, if we know the side lengths, side, we will have congruent triangles. Like if you're comparing two triangles and they both have the same side lengths, then yes, they're congruent. If you have side, angle, side, and they're the same for both triangles, then you'd say that they're congruent. And if you have an angle, side, and angle that are the same between two triangles, then they would be congruent. Okay? If you don't have those three cases, they're not congruent. And it doesn't have to be like all three, it's just one of the three here. Okay? Okay, so, and we've kind of talked about this a little bit. So we have option 1 is referred to as congruency by side. Option 2 is congruency by side, angle, side. And option 3 is congruency by angle, side, angle. Okay? I will not give you those codes. SSS, SAS, ASA. Okay, you need to know that. Okay? So, example 1. So here are two triangles. Okay? List the matching angles and sides. Okay? So anytime you have like a double line or a single line or an X, okay, we would consider those to be the same. Okay? So let's start with ABC. Okay, this is our proving stuff, okay? So we'll start with angle ABC. And what angle is angle ABC equal to in the second triangle?
Well, A and G. Oh, sorry, C and G.
C and G. Okay, yeah, so they both have X's, right? I'm talking about B right now, right? So what angle in our second triangle matches angle B in our first one?
L.
Yeah, L, right? Okay, so, and remember, that's going to be GLK, right? Because if that's in the middle. So angle ABC is equal to angle GLK.
I guess it doesn't really make a difference. Or it doesn't even make a difference if you would go KLG.
No, it wouldn't. As long as we have the correct letter in the middle, right? Okay. What other angles are the same in here?
A and K.
A and K, perfect. So angle CAB is equal to KGL. And what's the last one?
Oh, angle C and G.
Perfect. So angle ACB, right? And you guys got to get familiar with writing it in that notation too, okay? So don't just say angle C, you say angle ACB. Okay? And that one is equal to KLG.
Well, we messed up somehow.
Why?
We shouldn't have. We have two. Oh, never mind.
We're okay?
Yeah.
Okay, KLG, you're right. I should have gone KGL, right?
Yeah.
Or
Well, no, you should have gone because we're solving. We matched A with K.
KGL.
Right? We matched.
C8. Oh, I
No,
did
we
this one.
matched C
This one.
with
This
G.
one I did backwards. GKL. There we go. GKL, and then there we go. ACB. So LGK. Yeah, LGK. So, what do we know here? What is this? Is this a side length or an angle? That we know.
Like C or GLK.
Yeah, GLK and ABC.
An angle.
Angles. What about this one?
Angle.
Angle. And what about this one?
Angle.
Angle. Ah.
Is that
Ah.
one? A.
Ah. Is it one?
No.
No.
Not congruent.
No. Okay, good. Yeah. So AAA, not congruent. But what does it give us?
Angles.
Nope. If it's not a congruent triangle,
Oh, similar.
similar triangle. Yeah, it gives us similar. Okay? All good with that? Okay, example 2. Are these two triangles congruent? By what property? And we'll do this by listing matching angles and sides. So what do we know?
Well, W and Y are the same angle.
W, okay, so the length,
Yeah.
right? Because this, so when we see two lines like this, that means that are the same side lengths, okay?
And the line going across, that means that X and R are same length as well.
Okay, and just be careful, right? Because this is X to Z is line segment right here, right?
Yeah.
And then here goes Z to R.
What does that straight line up mean?
This thing,
Yeah.
that means that line segment X and Z and R are the same length,
Oh.
okay?
Okay, X just in the picture doesn't even look flat.
Say that again?
Never mind.
Yeah, and it doesn't have to be perfect as long as we have our symbols out there, right? So what do we know? What do we know?
That X and Z and R are the same length.
Okay, so how do we say line segments? XZ is equal to ZR, for sure. Okay, what else do we know? We know YZ is equal to ZW, right? And there's one more thing that we know here.
Well, we know X and R are both 90-degree angles, but oh.
No, we do not. We do not know that, Cody,
Oh.
because there's no right angle box.
Oh, never mind. We don't.
Okay. They look like right angles. I'll give you that. Yeah.
We know that Z, it's the same angle.
Okay.
Same
So angle YZX
It's the same as
is-
far as ZW.
RZW. Perfect. Okay. So we got 3 proofs. right? So what was this? Angle or side length?
XZ. Oh, that was side length.
YZ and ZW, is that an angle or a side length?
Side length.
And angle YZX?
Angle.
Angle. Okay. And remember, they need to be in like this orientation too, right?
Yeah.
And maybe I could have done this in a better order, but what do we have here? This is a side length.
Yeah,
Right?
you could have done your angle in between those two.
Yeah, I know, I should have done them in order, right? But that's okay, because we were just doing it as we saw them, right? And that's okay, because after you do that, you can just like go back and look at what we know, right?
Yeah.
So side, angle, side. Side, angle, side.
Yeah.
Congruent
Yes.
or similar?
Congruent.
Congruent. And by which theorem, Cody?
SAS.
Perfect. Great. Great, great, great.
Oh, Jones, do you have a pencil, man?
Oh.
It has lead. I thought it did.
Oh, come on, I want some pizza, Logan. Okay, example
You buy one every
3.
single day.
Yeah,
I
seriously.
don't have much.
Example 3. These two triangles are congruent.
Yeah.
So determine the value of x.
Well, we have 48 degrees and we have 90 degrees.
Yeah.
And 90 plus 48 is 138.
Oh, and
So 42 degrees is the other angle.
Okay.
then I
Okay,
think
but-
I know the other line.
Now you can go n minus.
We're looking for x though, right?
You
X
could use
minus.
15 and 6 to find it. Yeah.
Do you remember what that's called,
A
Logan?
squared plus B squared equals C squared.
Yeah, that is exactly it. And we also know that this is 15 centimeters, right? Because they are congruent triangles. It told us that, right?
Yeah.
And Logan, you're absolutely right. To solve for the side of x, so A, B, and C, A squared plus B squared is equal to C squared. Does anybody know what that is called?
Pythagoras theorem.
Yeah, perfect. Pythagorean theorem.
Theory.
I can't speak today. Pythag theorem.
Theory. Oh, it is theorem. Never mind.
Okay, Pythag. That's sad. Okay, so we know, so C is always the hypotenuse, right?
Yeah.
And we know the hypotenuse, and we know A, so we gotta solve for side B. Okay, how am I going to get B all by itself?
You're gonna divide, by a squared,
Divide,
or I guess minus.
minus A squared from
Yes.
one side,
No, put it on the other side.
both sides, right? Yep. Okay, so now we have B squared equals C squared minus A squared. How do I get that B by itself?
Well, first, divide by squared.
Square root it, right? Yeah. So divide by squared, take the square root, same thing.
Yeah.
Okay, so square and square root will cancel. Now we have B is equal to the square root of C squared minus A squared.
Let me check this.
Okay.
So,
C is 15.
225.
15 squared?
Yeah.
Okay, and minus A squared minus 6
36.
squared.
Alright, so we have.
Yeah, just give me 1 sec, okay?
71.
Yeah, so then you'll square 15, subtract 36, take the square root of that, and then you get, remember, anytime you take the square root of a number, you get how many solutions?
1.
2, right? A positive and a negative one.
So positive 16.46, 16.5.
13.7 is what I got.
I must have did it wrong on my phone then. Wait, maybe I
Probably.
forgot. Wait, what's 15 times?
If you did your phone.
Oh, I did 235. I forgot what I had for 15 squared.
Okay. So yeah, we get two solutions when you take the square root of something, right?
No.
But can we have a negative distance here?
Still got 16.1.
I got 13.7.
Just be careful with your brackets.
And it's on
And
my phone.
don't use your phone.
Yeah.
It's a trash calculator. Okay? We will not have a negative value for this question. Because we cannot have a negative distance, right? Okay, so there is that. Ooh, interesting. Okay, and that's everything for our notes. Okay, so you guys have two things to work on. Okay, so we have are we congruent Kagan worksheets? Okay, so work on the first. We'll go through two together. But just start working on them right now, please.